ratio. So sine ratio is a trigonometric ratio that only works on right angle triangles. So again, you're looking for that 90-degree corner here. Okay, and the sine ratio goes like this. It's an equation that says sine of theta. Theta is just a Greek letter. We use it to denote an angle of some sort. And that is equal to the opposite, I write it as OPP, over the hypotenuse, which I write as HYP. Okay, opposite over hypotenuse. So we need to know, okay, what is the opposite? What is the hypotenuse? What is theta? So let's take a look at this triangle and figure it out. So theta is just an angle. So if, for example, I put theta down here, we'll stick it there, we'll write theta, same as we would with like an x. Then the opposite side and the hypotenuse. Well, the hypotenuse we should know how to find. We just go to the right angle, and we go all the way across to the other side. And that should be our hypotenuse right there. Okay, but our opposite side is new. So looking at this angle, just like we did with the hypotenuse, we're going to go all the way across from this angle. So imagine this is like a camera or an eyeball, and it's looking all the way across. That is going to be your opposite side. Okay, so we can now use this formula to find missing parts of this triangle. So if we have two of these factors, we can find the third. Okay, so there's three types of problems we can use this in, and we'll take a look at all three. Okay, going to get us a clean page here. Let's take a look at the first one. Let's say we had a triangle that looks a little bit like this. You'll have to excuse the freehand here. We've got a right angle in the corner. We've got an angle down here. We'll call it 54 degrees. Say we have a side length over here of 19. And we'll say our unknown is over here. Our x is over here. Okay? So we take a look at our sides here. We want to label our sides here just so that we know what we're dealing with. Okay? So we know first, the easiest one to get, if we look at this right angle corner and we go all the way across, that one should be our hypotenuse. Okay, and if we look at this angle down here, think of it like an eyeball, look all the way across, that one should be our opposite side. Okay, so we have opposite and the angle, and we need the hypotenuse, so we can use sine here, which means we can use sine of theta equals opposite over hypotenuse. Now we can start subbing things in, subbing the things we know. So sine of 54 degrees. So notice that we don't replace this entire thing with 54 degrees, just the theta. Okay, so sine of 54 degrees equals the opposite of 19 over the hypotenuse of x. Okay, so now we have an equation, and we can solve equations. We just have to do a little bit of math here. Okay, so this works when we're finding the hypotenuse, this process. We want to get x on its own. And to do that, we need to get it out from underneath this fraction. So to get it out there, we're going to multiply it out here. So I'm going to take x and multiply it on both sides. That means that over here we now have x divided by x, and x divided by x just becomes 1. And since it's 1 times 19 now, we don't care about it anymore. So this entire equation becomes x times sine of 54 degrees equals 19. Getting closer. Now we just want x on its own, so we've got to get rid of this times 54. So we have times sine of 54, so we need to do the opposite of that to get rid of it. The opposite of times is divide, so we're going to take divided by, and then we divide by the thing we want to get rid of, so sine of 54. So note, it's not divided by sine, it's not divided by 54, it's divided by sine of 54. Sine of 54 is a number of itself. Sine isn't a number. Okay, we know that these will cancel, they become 1. And then because math is fair, we have to do the same thing to the other side. So divided by sine of 54 degrees. So if we were to rewrite this just for clarity, x equals 19 over sine of 54 degrees. Okay, almost there, home stretch here. So now we want to calculate the sine of 54. That can be done on your calculator. So some calculators like when you do sine and then you type the angle. Some calculators prefer that you do 54 and then press sine. Right? It really depends on the calculator. Most calculators that have a display that show you the equation will look like this. Most other calculators will prefer this way. So unfortunately, it really depends on what calculator you're using, so you'll have to check your own calculator. But when you calculate that, assuming that you are in degree mode, make sure you're in degree mode because we're working on degrees, not radians, not gradients, just degrees. Okay? So if we calculate that out, we'll get x equals 19 over, and then the sine of 54 is estimated at 0.809. I like to keep 4 decimal places, just for accuracy's sake. And then if we do that division again on the calculator, we get 23.5. Okay, so we went from just knowing the opposite and the angle to also knowing the hypotenuse. Okay, so that's one use for sine. We've found the hypotenuse. Let's take a look at finding the opposite side. So I'm going to get us a clean page here. So let's say we have a triangle that looks a little bit like this one. I'll turn it upside down here just so we can see it works even if it's upside down. Okay, we have a right angle up in the corner up here. Our unknown is going to be on this side. This is going to be our 13 down here and 27, oh, not 3. We'll go with 27 degrees in the corner here. Okay, so let's take a look here. So we've got our angle down here. We've got a right angle up here. So we know that this right angle, the opposite of that right angle, should be the hypotenuse. And the opposite of this angle here, again shooting, looking across, should be our opposite. So we have opposite and hypotenuse, so again, sine works. So sine of theta equals opposite of hypotenuse, and over hypotenuse rather. Okay, and then we just start filling in the things that we know. So sine of 27 degrees equals x over 13. And again, that's just taken from these over here. Okay, so now we have it set up. We've got x. We just need to find x on its own. So let's get rid of that 13. We have divided by 13. We need to do the opposite of that to get rid of it. Opposite of divide is multiply. So we're going to multiply by the thing we want to get rid of, 13. And that'll make it cancel. And then we do the same thing to the other side because math is fair. Okay, so to rewrite this just for clarity here, we've got 13 times the sine of 27 degrees equals x. So now we can just start solving this. So this, when we solve for that sine, will be 13 times 0.4540. Again, just keeping those 4 decimal places for the sake of accuracy until the end of the question. And that equals x. And then if we multiply those together, we get 5.9 equals x. So it's a little bit easier to find that opposite since we don't have to do that extra step in the middle. But same kind of process, you know, just use the equation, solve for x, and then solve the equation in your calculator. Okay, so we've looked at hypotenuse, we've looked at the opposite. Let's look at the last thing that you can do with sine, which is to find the angle. Okay, this one's a little bit different, but not harder. Okay, let's get ourselves a clean page here. And we'll write one more triangle here, so just like that, with a nice right angle in the corner. So this time we've got a side length of 30, a side length of 39, and some angle that we don't know. Okay, so we don't know this angle we're going to be solving for it, but we do know where it is, so we can still label the triangle. Okay, so we've got our right angle here, so we know that the opposite of the right angle should be hypotenuse. I'm going to zip into this since we've already done this a couple times. We know the angles here, so we imagine it's an eyeball shooting across, like a cyclops or something. That'll be your opposite side. Okay, so we have opposite and hypotenuse, so we can use sine. Sine of theta equals the opposite over the hypotenuse. I like to write that out every time so I don't forget. It's really useful for me because if I do it wrong, then at least I can look at the top and say, oh, I took the wrong side. I know why now. Okay, but now we can fill in things we know. Sine of, we don't know theta this time, so theta stays there. And then the opposite is 30. The hypotenuse is 39. Okay, so right away, we know that we can do 30 divided by 39. That's simple enough to do, so why don't we just solve that first? So sine of theta equals 30 divided by 39 equals roughly 0.7692. So now we're left with a dilemma. We've got theta, but we've got sine of theta. So we need to get rid of this sine. So just like we get rid of things like multiplying and dividing, to get rid of it, we need to do its opposite. It turns out that the opposite of sine, the reverse of sine, is the inverse of sine. So we have a function. This will be on every calculator that you ever see that has trigonometry functions. It looks a little like this, sine minus 1. Okay? It might also look like a sine or arc sine. It depends on your calculator, but the most common one is this sine minus 1, this inverse sine. Okay? And what that does is it just gets rid of the sine to leave us with theta. But we'll remember that math is fair, so we have to do the same thing to the other side. So the inverse sine of 0.7692. And if you do that on the calculator, you should get your answer. Theta equals 50.3 degrees. Okay, so we've looked at how to find both sides in the sine ratio and how to find the angle. So that should cover every sine question that you could possibly come up with. And you should be able to solve any triangle that has both the opposite and the hypotenuse in it, as long as it has a right angle.